So let's take a look at the comprehensive exercise of chapter 5. So let's suppose you just turned 30 and you would like to retire when you're 60. So the time period is like from 30 to 60, which is 30 years. And you will need $1 million in your retirement account when you turn 60. And for the next 20 years, so you're 30 now, and for the next 20 years, so until 50, you will be able to deposit $7,500 semi-annually into the account. So every 6 months, you will be able to deposit $7,500. And at age 50, okay, after you deposit $7,500 semi-annually, you would plan to withdraw $100,000 to purchase a car. Okay, so that's what it's gonna happen until you turn 50. And if your retirement account's annual interest rate was 5%, but it was always compounded semi-annually, so that means every 6 months you will be charged half of this annual interest rate, which is 2.5%. How much will you need to deposit into it every 6 months for the last 10 years of your career? So to better understand what the problem is trying to tell you and what it's asking, you might as well, for this kind of long problem, you might as well draw your own timeline that will help you comprehend the question. So from your age 30 to age 50, so with this time period, before you start, it's really the best if you could separate the time period and just divide it into different segments. So the first segment, which is from age 30 to 50, what you're planning to do is you will be depositing $7,500 at 2.5% for 40 times, because this is 20 years and this is happening every 6 months. You'll have to multiply by 2. All right, so that's what's going to happen for the first 20 years. And when you turn 50, you will be withdrawing $100,000 from your account to purchase a car. So that's the second activity that you need to take into account. Finally, for the last 10-year period, which is from age 50 to 60, you will be depositing additional amounts. You don't know how much that is, but whatever that amount is, you will keep depositing, but it's obviously not going to be $7,500, right? So whatever the amount is, you're going to deposit at the same 2.5% because you didn't change your account. So the interest rate will be the same. And that will happen for 20 times, because this 10-year, in terms of 6 months, it will be 20. Okay, so with that, you would like to achieve a goal of $1 million. So you wanted to have $1 million when you're retiring, and by just working on working with your work. So with this time schedule, you would like to achieve $1 million when you turn 60. So step 1, you would like to know how much you would have by 50 by making the deposits like this, all right? $7,500 at 2.5% for 40 times. How much would that be in age 50? So in a sense, you're trying to figure out the future values, because if you just take a look at it here, this is your present time, this is gonna be the future. So you would like to know how much your future value would be. So if you just input the amounts according to this calculator key input and compute future value, then you would be able to figure out the amount. I'm going to skip the calculator process because it's very straightforward. You just have to input it as you would with any other problem. And what you will have by the age of 50 is $505,519. Okay, this is the dollar amount of your account balance when you turn 50. Second step. From your deposit balance, you would like to withdraw a certain amount so that you can purchase a car, right? So what you had from the earlier step was 505,519. From there, you're going to withdraw $100,000. So the remaining balance will be 405,519. So this is the amount after your car purchase. Step 3, you're going to start over. So you right now have 405, 509 when you're 50. And then you're going to make additional deposits so that you will achieve $1 million in age 60. If that were the case, how much would you need to deposit so that starting from 405, you can still achieve 1 million? All right. So that will be the question here. So this one is slightly different than any problem that you did before because you have present value, which is 405. So if you're just kind of making a time shift, let's suppose you are now age 50 and you would like to figure out how much you need to deposit more so that in the future when you turn 60 you would have 1 million. So you have the present value and you have future value, and you will have to input both present value and future value to figure out the payment, the regular deposit amounts. So what would you need to input for your calculator? So the time period here is 26 months, so 20 and interest rate being 2.5. And then here is the thing that you need to watch out for. So take caution here. For present value, if you think about this present value, 405, 509, this is the amount that is just kept in your bank account, meaning that it's more like an amount that is just away from, so it's away from your pocket. So this will still have to be input as a negative value. Remember, anything that comes into your pocket will be positive. Anything that gets out of your pocket or away from your pocket is negative. So you're going to input that as negative 405, 5, and 9. Finally, when you turn 60, you're going to withdraw $1 million from your bank account into your pocket. So this is positive, all right? So 1 million as future value. So you need to input the numbers into the key variables like this. Let's compute payment, and it will give you negative 13,314. So every 6 months, you'll need to deposit or take 13,314 out of your pocket and deposit into your bank account so that in the final moment of this time period, you will have $1 million in your pocket. Now let's extend the earlier exercise. So continued from exercise 1. Let's suppose you're starting from age 60 and let's suppose you have a time shift and you're now 60 and you have $1 million in your bank account. When you retire, you will transfer your money to a different account that earns an annual interest of 6%, and this time it's going to be compounded monthly. And this is the source of your living. So you will withdraw an equal amount like an allowance at the end of every month for the next 25 years. Okay, so that's going to be your allowance. And age 85, you wish to leave $500,000 for your son. And if that were the case, how much can you withdraw every month? All right, so that was the question. Once again, you need to draw a timeline. So everything that happened before is just from the past, so you're not just taking that into account. We're just starting over again from age 60. So 60, you have $1 million. And from here, you're going to withdraw a certain allowance every month. And then after 25 years, about at age 85, you would like to leave $500,000 to your son. After just taking out as much as you could, okay, for the 25 years. And you would like to know how much you can withdraw every month with this information given. So present value, so as I told you, we have made a time shift, and right now the present value is $1 million. You're just living in this day and your age is 60. So $1 million to start with. You will be just withdrawing a certain amount from there, and then you would like to still be able to withdraw $500,000 so that you can leave it for your son. So how would you input your calculator? So you're looking for a payment, you need additional variables to input. So if it were monthly compounding, and then you would have to input months as your number of periods, and that would be 300. 25 times 12, that means 300 months. And then in terms of interest rate, it was 6% annually, so you divide by 12 to have it as 0.5 for your interest rate. And then present value, future value will be probably more important. So $1 million, remember how it said it was being transferred to a different account, so it's still away from your pocket. All right, so it was just merely transferred from one account to the other. So it's still just not into your pocket, so it's negative. And then by the time you're just passing away or leaving it for your son, it will come back to you. It's just withdrawn from the bank, and it was first put into your pocket. Even though you just passed away, it's still your money, either your money or your son's money. So 500,000 is plus, right? And note that the signs are different. Okay, even if you were confused, at least you would have to have different signs for present value and future value. Just take that into note. And then after just inputting all these variables, let's compute payment, and it will give you 5721.51. So every month you'll be able to withdraw 5721 from your bank account, and you will be able to use that for your living. Okay, so just try to comprehend what this problem is trying to do and how you can apply, this rule into one of your quiz questions, and this will help.